All right, hi everyone, it's Mrs. Han-Baral. Just doing a quick video about complex fractions. Hopefully you guys are all staying safe and at home. So complex fractions aren't really that all complex. They're just a fraction within a fraction, which is really just a division problem using fractions. So I have two examples that I'm going to do here. So you could have a whole number mixed in, or you could just have two fractions together. So in the first example, it says 4 over 1/3. So this line is clearly a little bit longer, which is why it tells you that it's actually 4 divided by 1/3. And we know that when you divide with fractions, you're actually multiplying by the reciprocal, or you flip the numerator and denominator, right? Remember our fraction family song? Division is a trip, the second number you flip, then you multiply them, right? And of course, 4 as a whole number is the same thing as 4 over 1. So I'm going to rewrite this problem as 4 over 1 times 3 over 1. And of course, that would give me 12 over 1, or 12. If you think about this using some common sense, it is a reasonable answer, because if you divide one whole into 1/3 pieces, there would be 3. So then if you have 4 wholes, it would end up being 12 1/3 pieces. You kind of have to retrain your brain, because normally when you divide numbers, they get smaller, but when fractions are thrown into a mix, a lot of times the numbers get bigger. For our second example, it's 2/5 divided by 10 over 11, and one of the lines might not necessarily be longer than the other, but you know that since there are two fractions, it's 2/5 divided by 10 over 11. And then of course, like we did before, we would rewrite it into a multiplication problem. So 2/5 times the reciprocal, or 11 over 10. And then I know a lot of you like to skip this cross-canceling step, but it really is important to practice. And later on in algebra, when we use variables, it's actually unavoidable. So if you can practice it now, you're better off. So the way it works is, if you have a numerator of one fraction and a denominator of another fraction that share a common factor, then you can factor it out and simplify the problem. So here I noticed that 2 and 10 are both divisible by 2. So 2 divided by 2 is 1, 10 divided by 2 is 5, and now I can multiply straight across. 1 times 11 is 11, 5 times 5 is 25, and it's already in simplest form. If I hadn't done that, I would have gotten 2 times 11, which is 22, over 5 times 10, which is 50, and then I would have to simplify to 11 over 25. In this case, it wasn't that big of a deal, but you can imagine that, if I had a problem like 8/9, and it was times, 81 over 64, just as an example, I really wouldn't want to waste all my time and multiply those out when I could easily cross-cancel and know right away that my answer is 9 over 8. So, it definitely does make things a lot more efficient. All right, hope this helps. Talk to you soon. Bye-bye.